This episode of Hak5 is brought to you by Domain.com.
Hello and welcome to Hak5. My name is Darren Kitchen.
My name is Shannon Morse.
It's your weekly dose of technologist, and we have a fantastic show for you guys this week.
Yes, we do. I would like to introduce somebody new to the show.
There's a newcomer?
Yes, this is our new friend. What are we calling her?
Oh, this is Frappuccino?
Frappuccino?
Yeah.
Yeah.
Well, it turns out you can repurpose items from your local coffee shop. No, this is actually my personal FPV
I love how
quad,
you did that.
And we'll get into that
Frappuccino
more
is looking great.
Thank you. I
She
pride
looks
myself
good.
on her zip ties and Velcro. That's pretty much all that's holding her together. A couple of M3 screws later. We're actually talking about more drone stuff this week. Peter's back with us, and we're up in the Eugene, Oregon, back with the mustache, talking about the drones, putting one together.
The stash.
I know.
That's stash.
You know what else, though? In addition to the comments that I need to comb and need to shave and all of those other things, thank you. These are the important comments, by the way. We got a comment that we don't seem to be having enough fun on this show.
Wait, seriously?
Mm-hmm.
Oh.
And you know what I found?
How can we fix
Just for this occasion, I happened to come across, I guess as we were doing some spring cleaning here. Do you remember these?
Oh,
That's not a gift from a fan. That's a gift from me to
you.
There are now, how many?
Look at that. Do you see that?
There are
Hak
11 of
5.
these. There are now 11 of these in existence.
Oh my god. I
Right.
remember when you made these. So
Actually,
it says
hang on.
Hak5 on one side and trust your technologist on the other.
I guess it's not
They're
11
quite
actually. Because
lovely.
it's 11,
Oh no.
10.
How are we doing this? I need
There's only
a chase.
10 left.
I
Here
need
you
a,
go.
just a little bit.
Just a little bit?
Teeny
Just
tiny
a little
bit.
bit? Just-
I have to drive home
just-
later in a few
Okay.
hours. Okay, that's fine.
There we go.
Wow, it's so
So there's
syrupy.
9 available now. Yeah, it's pretty much. It's called Cringe. Cheers.
Well, at least it tastes like cinnamon.
Well, drink it already. It's fantastic.
But I need a chaser.
I'll chase you around the set.
No, I need a chaser. Do you have soda?
Oh man,
Do you have
that
some,
is so bad.
Do you have some soda? You have soda? All right.
Are we doing this?
He has
for
a
real?
soda.
Yeah, we just had a shot. Are you having a shot too?
Yeah.
Okay. So there's actually
Okay,
8
I
shot
did it.
glasses left. This one's going to Sarah in the hack shop. Who appreciates? Here you go.
Oh man, I am so not into liquor. I'm
I hardly
28
knew her.
years old and I should be, but not into liquor.
Anyway,
Beer and wine right here.
Yes.
Give me a Yingling
with
and some
that
red
out
wine.
Of the way, we also got a legitimate question here, which was about a few of these, in fact, about the solar-powered
Burns!
pineapple case from last week, and just some specs on it. And honestly, I thought that we covered this, and I have talked about solar in the past before, but this is stupid simple. We can actually come back at this with a sexier design, something maybe in a much smaller, more covert Pelican case. I think that should be apt with, like, I don't know, lithium batteries instead of lead acid, but all that's inside of here is we got, what is this, a 10-watt panel on the roof. We've drilled some holes for our antennas, mounted our 14 dBi panel antenna as well as our 9 dBi dipole and our coaxial collinear for ADS-B. And then on the inside, all we have is our Wi-Fi Pineapple and just a big-ass lead-acid battery. And this is simply the least expensive 12-volt charge controller you're going to find. In fact, I think it came with the kit. It's nothing fancy, not like the one in the van, but essentially all of these do the same thing, which is a 3-phase charging where it does a bulk phase and a trickle phase, and I forget the other phase, but essentially it gives power and then it makes it through the night.
I love it.
Yes.
It works well. And
it's so
worked
covert.
great for our
As a lot of
segment
people
last
have pointed out in the comments, it's totally, no one would notice this if it was in the
Yeah, of course not.
on the hill.
So I'm taking our segment from last week and I'm growing this week's segment off of that, and we're bringing in Rob to talk to us.
Which
Archiver.
Rob? There are two. There's
Archiver.
Archiver, and then there's the other
And then
Rob,
there's
the Mubix
Mubix.
Rob.
That's
Right.
true.
Yes.
Yeah, Archiver.
And by the way, no one has ever seen both of these Robs in the same place at once. Coincidence? I'm just saying.
It's the same person. He's just a Cylon. So there's 2 of them.
Actually, the Cylons are parked over by the bay, and they carry oil from the refinery. We've covered this on the AIS segments.
Okay, maybe we should get into the first segment.
Yeah, let's get into the first segment.
Okay, bye.
And we're back with our drone series here. And Peter, I have just a quick question, just something brief. And that is, we've been talking about how with this remote controlled quadcopter here, how I can give it input with my remote control and it will, you say, pitch forward or do what I tell it to do. And that all just goes into the flight controller. And then there's a hamster.
Happening?
There's a hamster on a wheel in the flight controller, and then yes, it does
sitting on stakes and controlling
intelligent stuff. How exactly does that work?
So what you have there is, as we mentioned in the last segment too, there are some sensors on this. So you are sending some commands to the flight controller from the ground.
Yes, I'm saying pitch forward.
Pitch forward, and then the controller takes that into account together with its own representation of where it is. So there are some sensors like gyroscopes, accelerometers. We will get into that in detail in a minute. These are being used to tell the microcontroller where it is in the world. So if it is tilted, how fast it is turning, and then using that information, it takes what you want it to do into account, and then it does what you asked it to do. Why do you need to do that?
Well, we were talking about previously how, like, even if you're the most badass fighter jet pilot, you've got maybe a 10 hertz response rate, and this needs to have something 10 times that to stay aloft, or else you're just fighting with it and it's just going to be jerking around and crashing.
That's right. That's right. So basically you have a second person that is inside the aircraft.
Co-pilot.
Co-pilot.
That sounds a lot better than autopilot, in fact.
Yeah. And actually there used to be co-pilot modules for airplanes and stuff in the past for RC airplanes.
That's interesting. See, now I need a bumper sticker that says, my co-pilot is open source. We'll get to that.
That's pretty good. Yeah, that's exactly what is happening here. You have an electronic co-pilot on board of the aircraft, and the co-pilot has to know how it is flying because it is the faster one. It's the faster one of us too.
So I'm really saying, like, hey, go forwards, and it's like, well, based on all of this stuff, the best way to go forward would be like this.
Like this, right.
Okay, so how does it, like, what are those sensors, aside from my input, what are the other sensors that it knows about itself?
Right, so the most basic sensor that you have in the most basic setup is a 3-axis gyroscope. You could even have a mechanical one. That's when we started with this hobby, this is what was happening.
Well,
you had a
like
mechanical
the first ever like ICBMs had mechanical gyroscopes.
And also X-UFO, that was a very early toy a quadrocopter toy, had a mechanical gyroscope inside. So by now we have much more sophisticated thanks to our cell phones, so it is much smaller, it's barely visible.
Right.
So if you take one of those boards.
So this is a very basic flight controller, and it has a 3-axis gyroscope in it. In fact, very similar to what's inside of this like off-the-shelf toy, which has a 3-axis gyroscope. What does that mean? First of all, what are those axes and what is a gyroscope doing for me? Yeah,
that's right. There is a big difference between a mechanical gyroscope and the MEMS gyroscopes that we know of. So MEMS gyroscopes can measure the rotation rate of an object around one linear axis. So we have 3 of them, and we have 3 axes. Again, we define where front is, so let's say this is X, then we have Y, and then we have Z.
Sure. And
we have, for each axis, we have one gyroscope that is telling you how fast are you rotating along this axis. So if you are not rotating, 0 rotation speed.
So it actually doesn't know, like, what your pitch is, it knows what your rate of pitch is.
That's right.
So, for example, like with this is a very basic toy that only has a 3-axis gyro, and if I hold this down sideways while I plug in the battery, it's going to get very upset, and it's not going to, in fact, if I try to fly it now, it's going to just crash, because I was holding it sideways. Now,
No, almost there. It's actually.
Well, there's a calibration.
Yeah,
thing
there's
for
a
this
calibration,
particular
but
one where you set it on a flat
what
surface.
is the important thing is like when you're starting almost every autopilot, it's like don't rotate it while it is doing its startup. That's actually, you are trying to find where the zero rotation speed is, because when you switch it on, it will take the current value. It's like because of the sensors, how accurate they are, and then they basically take the zero value of zero rotation when you put them on the ground. So you plug it in, you get the zero value, and then if you were rotating it while it was doing that, then it would think, oh, rotating like this means zero.
Means zero. So it's going to try to do that in order to stay stable.
Stable, exactly.
Yes.
So don't do it.
Okay.
What happens there, as you said, with this very basic quadrotors, is when you're commanding with the stick to pitch forward, you're actually commanding it to rotate with a certain speed forward.
So rotate with that certain speed forward like this. Now, what's the problem with that, though? If I'm like controlling this and I say, "Hey, tilt forward," there's no problem.
There's no problem with it.
It flies.
It's still, yeah. You have to do more.
As a hacker, I want like all of the features.
What is the next step up to make it cooler? It's like or better or easier to fly.
Because like on my stick, if I'm saying rotate forward and then I just let go,
then it will stay that way,
it's just
and
then
it will continue flying.
Bye. Bye, quadcopter.
And then you have to pull it back, and it's like, oh yeah, is it like now level somewhat? And you have to do the leveling.
Right.
So what do you do there? You take accelerometers. It's a 3-axis accelerometer. So what it does, it gives you the acceleration along this 3-axis XYZ, as we described for the gyroscopes. And what it actually measures is how fast you are accelerating to the ground.
Okay, how fast am I accelerating to the ground right now?
1g. So 9 meters per second, roughly.
I am in fact falling towards the Earth in space. Like
accelerating
I'm accelerating towards the core of the planet.
Yeah, but there's the ground in the way.
There's ground. Thank God. I am really thankful for gravity right now.
Yes, exactly.
And so you're saying, like, for instance, this one, sometimes they call them a 6-axis gyro or something. What they mean is it's got, there's only 3 axes, X, Y, Z of your gyroscope to, again, like you said, know the roll
how fast
rate,
you're rotating,
right? And then 3 more axes of accelerometer.
Know where down is.
Oh, I see. So it knows along this axis what down is, and along that axis what down is.
Yeah, you tilt this guy up, and then still it is the g vector or the Earth acceleration vector is down. So it now knows. It's like, I'm not rotating at the moment, but I'm still tilted.
Got it. Oh.
So now,
so this is why on the nicer ones, on the more advanced, off-the-shelf stuff that has that accelerometer, you can let go of it, and it's what they call auto leveling, where it knows that it's tilting forward and it can right itself.
That's exactly right. That's what it's exactly doing.
Cool. And so I take it, when I tell it to do something and it takes into account that information, when we're just talking about gyroscopes, there's probably some complex math that requires Lisp or something complex to write, where it will kind of come up with a solution to then tell whatever our actuators are, the things that actually cause flight, or in our case, the rotors.
Well, the math can be as complicated as you want to make it, basically. It's like you can start with actually quite simple math with Euler representation of your angles, and then you just take the gyroscope speed, you write a simple PID controller. It's just actually quite a basic controller concept.
So what he's saying is like 2 lines of Perl.
No, it's 2 lines of C, actually. It's really? 2 equations or 3 equations that you put in.
What he's saying is like 8 characters of Perl, actually.
Exactly. No, this is actually, it's like when you look at it, and it's actually not that hard.
Okay.
In the basic level, it's like you can make it more sophisticated to be more accurate.
Well, that's what I'm saying is I
things.
Want more sophisticated. I want to say have the gyroscopes as well as the accelerometers. In fact, there are others, and I take it the more sensors you have, the better of an intelligent decision the flight controller can make as far as telling, in our case, motors what to do.
Yeah, you can figure out you can basically not only make a decision about it, it's also the way you are figuring out where you are in the world and dealing with the sensors have noise, have errors, how you deal with those.
Oh, that's interesting, right? Because another sensor that, for instance, this one has is a barometer.
Right.
Now, a barometer measures air pressure, and now it's not perfect. In fact, this one has, there's like a piece of little foam that has to stick on top of it, and it's not going to work so great in a storm or something like that. Like it's rainy outside right now, so it wouldn't really work the greatest because there may be a lot of variation.
Yeah, if it's like windy or like gusty or something, then it will, because this is the interesting part. It's like we are talking here about pressure in like millipascal. It's like change 10 cent. They are incredibly sensitive. They are that sensitive that they are actually better temperature sensors than pressure sensors.
Wow. Well, but I guess what I'm getting at is that the more sensors that you can tie into the mix, each sensor can check the other sensor. You can kind of weight different things. You can come up with, I'm sure there's fancy algorithms.
Yeah, you get more of a absolute reference to the world. The more absolute reference to the world you have and less relative to your previous state, the more accurate you can make it.
Sure,
and yes,
I mean, I've seen
then you go at some point to Kalman filters where you have real matrix calculations or even adaptive filters that adjust their gains based on some estimation. It can get really, really cool.
It sounds awesome. I mean, so I guess what we're getting at here is the more sensors, the better, and how you deal with those sensors is really what.
The better for us. The better for us.
Yes, more to work with. For instance, we haven't talked about this yet, but I know that one of the first, drones to hit the scenes commercially, as far as like, I think Shannon reviewed it a couple of years ago at CES, was this Parrot AR drone, and it worked with stereoscopic cameras that pointed towards the ground.
Yeah, no, it is a single camera.
Oh, a single camera.
It's a single camera. Yeah. It does optic flow directly in the chip.
It's kind of similar to, say, your optical mouse. In a way.
In a way. But the disadvantage used to be like if you don't have enough features on the ground and it's too smooth.
Just like how old optical mice didn't work very well on surfaces that were all the same color or whatever.
That's right.
Okay, so there are, these we've just been talking about, these are toys, right? And they implement various levels of different
and basically when you buy them, you just get a flying controller in it.
We're not interested in that. We want to make something cool, something with RAID hard drives and liquid cooling and overclocked video cards, except applied to aerospace.
Yeah.
So what is available? Like, if I just wanted to get flying, what do I need, flight controller-wise?
Flight controller-wise, it's huge selection. There's what we actually want is something. So there are commercial ones. There are also professional ones. We will not talk about the professional ones because I don't think
it's outside of the scope of this.
It's a bit outside of the scope.
In fact, let's go ahead and already nix this guy. This is one of your more common...
It's very, very popular,
proprietary one. This is from a company out of China. It's called DJI, and it's called a NASA flight controller. And it's very popular. We've used it, in fact, in the previous segment where we took a drone to the top of Mount Diablo to do some ADS-B research. We used one because it was off the shelf and didn't have to do anything. Plugged in the battery, turned it on, and away we go. Which is okay, sure. And I could tell you, just go buy an iMac and you're done. But that's not the way we do things. So thank you very much, NASA. But let's go with the open source.
Open source stuff.
Yes, I want to get like Linux. That's
yeah. So we have several players. It's like everyone a little bit more familiar.
It's like distributions, right? You've got your Gentus, you've got your Ubuntu's, you've got your Mint, you've got your Arch.
We left the macOS and Windows out of the equation now. So let's look at the open source stuff, right? There is also very known, it's ArduPilot. It's based on Arduino, and it is very commonly spread, and you can buy it in almost around the corner.
That's awesome. Well, I mean, I love Arduino. It's open hardware. That's a very cool thing. there's another one that's based on some other
it's
popular commercial, like kind of a hack together.
Oh, right, yes.
There's the multi-Wii, which kind of has lineage from, we were talking about how these MEMS sensors, these IMUs as they're called, these inertial measurement units and stuff, have become so inexpensive because of cell phone technology that they then found their way into that gimmicky game console, the Nintendo Wii, and because that was
it's
cheap
basically
and
the
available.
nunchuck. I think from the nunchuck.
From the
part.
nunchuck?
The
Okay.
nunchuck. I think there is like a small, tiny board inside that has the gyroscopes on it, and you can pull it out.
So they just hacked that out.
Yeah, and they took an Arduino, plugged in this board in the other one, wrote some software, and got it to fly. It's a beautiful hack. I love this.
I love that kind of stuff. There's also some other bigger players as well. We've got Pixhawk.
Pixhawk,
In
yes.
fact, that's what I have an example of that in the Iris drone we have from 3D Robotics. However, it is not running the Pixhawk firmware. In fact, it's running stuff from another project.
Yeah, it's from ArduPilot, I think, ported over. It's like, they have their own firmware for it. You can play around and swap things around, and like if someone ports to one hardware to the other, because at the core, these boards are actually quite similar from what they provide.
Sure, and they're not x86 obviously, but you know, these are little microcontrollers, various like Atmega, so things from Atmel or things from different ARM vendors, in fact.
Yeah, I think there were some projects based on PIC, but Atmega was huge and everyone was using it for many years.
Yeah.
And now they are being replaced by Cortex M3 ARM 32-bit processors, and this is like pushing away the Atmega out of it when people start to want to do more sophisticated algorithms and spread their algorithmic wings.
Yes, no pun intended. So another popular one, in fact, would be OpenPilot.
Yes.
So this is an OpenPilot board. In fact, another example of an open hardware where this is an implementation from, what was the company that does this one again? The orange one?
This is Ready-Made IC.
Okay.
These are the guys making this.
So
there's a yellow one and a black one. This is basically
and then
the
I've seen
choice,
a white one as well.
Yeah,
and so,
it depends on which vendor you're getting it from. There are several vendors that they
because
have.
it's open hardware, that can be the case. And this is really popular with the FPV flyers. And I'm going to be implementing one in a separate project for a small 250 class quad just for first-person view flying. And then we come to, and this is why we're here and why we're with Piotr, then we come to the paparazzi.
Yeah, paparazzi UAV. Yeah, this is an open source project that actually has been out there for quite a while. It's started in about 10 years ago when they started to make autopilots, and actually for fixed wings first, and then added quadrotors to the system. So we have, what is great about paparazzi is that it is not, it is quite controller or autopilot agnostic. It's like anything you want to port it to, have fun. And there is a huge amount of different autopilots depending on the application, who developed it, and they are mostly open hardware. I think all of them are actually open hardware. And
so you're saying that the hardware is vastly decoupled from, for example, the
actually
software,
the project
which is
started with an Atmega, then got ported to an LPC ARM, and then to STM32, and so and there's also a port just to PC to run it on Linux directly, the complete controller.
So let's just put a ThinkPad on this, and we'll be good to go.
Yeah, no, actually, for real.
No way.
Yeah, people are able to port it to this mini PCs
there's an
or
x86 running.
Yeah.
That's awesome. That is so cool.
Yeah, you can do that. It's like paparazzi it's flexibility in every aspect.
So in some ways, well, we have, for instance, we've got our auto quads and our UAV PNGs and our open pilots and those that are, some of them may be of various levels like distros. We know you've got your Linux Mints and your Ubuntus and then your Debians, and as you put more in, you can get more out. The paparazzi is kind of more like a Gentoo.
Yeah,
It's like, if you're comfortable compiling it yourself or something like that, you can get a lot more performance out of it.
Yes, that's exactly right. It's like the idea is we are not telling you what you want. You are telling us what you want. Basically, you take the whole framework, the whole Paparazzi framework, you download it, and you configure it to your needs. You compile it to the right processor and board.
As you just said, as the example of it running on an x86 board is a good example of, like, you know, imagine that, and then take a look at this implementation. This is what, a centimeter by a centimeter? Is it
it's
even
2 by 2? It's
2 by 2 centimeters, and this implements how many sensors now?
So this one has, additionally to the default 3-axis accelerometer, 3-axis gyroscope, 3-axis magnetometer, also a GPS receiver on board, and a pressure sensor.
So this is a magnetometer and a GPS receiver.
So this is a GPS receiver, that's correct. And on the other side, when you turn it around, you have barometer, so pressure sensor. You have in 3-axis magnetometer over here, and then
so the magnometer or magnometer. How can I not pronounce that? Magnetometer. Anyway, it knows where north is, and that's a good thing.
Yeah, and also its inclination. That's also interesting.
Oh, cool.
Yeah.
Wow.
So.
Coupled with that, the barometer and the GPS, I can't believe how small that is for all of those sensors. So it can.
It's a basic set of sensors that you need to completely autonomously fly around.
This thing.
Yes.
That's a lot smaller than an x86 board. Yes. Okay, this is really cool. So I guess we have to give mad props to everybody, though, in this open source community.
Yeah, no, definitely.
And we are going to go ahead and continue this series with the Paparazzi. I'm eager to get our Lisa M board, as it were, plugged into the computer and set up so we can actually start programming this guy, get some motors spinning, and get to flying. Thank you, Peter.
Let's do it.
All right, we'll be right back. I had a brilliant idea the other day. Wi-Fi enabled birdhouses. So I went to the pub and I told all my friends, and they were all like, dude, that's a brilliant idea. And I was like, man, I should tell the world. And then I thought about it and I was like, you know what? I could put it on the World Wide Web. And you know what? When I go to do that, I get myself a fresh domain, and I pick them over at domain.com because it's got a quick domain discovery system and an easy checkout process, and you can have your website up and running in no time, and I love that. So no time like the time when your domain is set up, and I love that. And domain.com loves Hak5, and we love them because they're affordable, reliable, and easy to use. And also they're really fun to deal with on social media. So you can tweet them and be like, hey, why are you guys still sponsoring Hak5? Those guys are crazy. But you know what else is crazy? The savings! You use the coupon code HAK5 at checkout, you get an extra 15% off at domain.com. So when you think domain names, think domain.com.
We're back, and it's now time for the trivia question of the week. So last week's trivia question was, the last version of Windows to use FAT as the default file system was what? And the answer was Windows ME. Now this week's trivia question is, who coined the term robot? And you can answer that over at hak5.org/trivia. Beware of the panda, and good luck. We're back in the office this week, and I decided to have some more fun with virtual radar servers. So if you guys remember last week, we basically decided to take the Wi-Fi Pineapple out, stick it on top of a hill with a solar panel so that it charges for like 3 days, and we stuck an antenna on it. We went back here to our office, connected to our internets, stuck an antenna out the window directly at the hill, so we were able to get all sorts of really, really cool airplane tracking going on from our Wi-Fi Pineapple on the hill straight down to here. So we didn't even have to leave the office once we got it all connected. It was awesome. We had it running for several days with no problems at all. And luckily nobody ended up taking our Wi-Fi Pineapple. Well, we thought about it and we figured, wouldn't it be really cool to not just use our local network, but to also connect to somebody's Wi-Fi Pineapple really, really far away? So that's exactly what I did this week. And we are bringing in Mr. Rob, aka Archiver. Hi, Archiver, how are you?
Hey, Shannon, how's things?
Hi, it's so good to have you back on the show again. So if you guys remember, Archiver is one of our longtime friends. He's from Ireland. He lives over in Dublin. I hope you don't mind me sharing where you are.
No, not at all.
Okay, good. So you have a Wi-Fi Pineapple connected. Where do you have it exactly? Is it sitting in your house?
It's actually out on my balcony,
Ah.
which is facing Dublin Airport.
Oh, that's perfect. How far away are you from the airport?
About 5 kilometers as the crow flies.
Okay, that's awesome. So
literally
we're going to
straight
get
line.
some good airplane action going on. So what we did this week, we had Archiver set up his Wi-Fi Pineapple, and Archiver, can you tell everybody how you go through the process of setting it up so that we can get the airplane tracking happening?
Oh, sure, not a problem. Basically, as you had it last week on the show, I plug in my Pineapple, plug the SDR dongle into it, power it all up. Now I have it set so it connects straight into my Wi-Fi. Upon power up, it knows what to look for and connect in. Just check it in, make sure that it's broadcasting out correctly, and make sure that my port 30003 on my router, it just goes straight through to the Pineapple. Gave you my IP address, and away we go.
Awesome. All right, so what I did on my own computer, I still have Virtual Radar Server installed, so I went ahead and got that. If you haven't downloaded it yet, you can get it at virtualradarserver.co.uk. This is an open source .NET application, so you can have lots and lots of fun with it. It has plenty of customizable applications for its map, so you can have lots of fun with it. So if I open it up, I went ahead and included his Pineapple down here, and I called it Archiver. If you want to add a new one, you just go to Tools, go down to Options, and then choose Receivers and include the new one. So I have his right here. Well, don't worry, we'll blur your IP address so nobody can see it. So I included his name right here.
Oh no.
His external IP address and the port number, and that's all you have to change. So once I tested the connection can be made with these settings. Click OK, choose OK, and then I have it down there. So I can already see that we get tons and tons of messages coming through here from overseas, which totally blows my mind, but it works. I love this about it. Once you have everything ready to go, you click Take Online. Mine says Take Offline right now because it is running online, and then you can click on 127.0.0.1/virtual radar, and you should get a map. Now, if the map does show up in your local area, so for me it's way over here in the United States, you can still see my little blue dot down there. You can just scroll over to wherever you have the Wi-Fi Pineapple set up. So you should probably know the location beforehand. That would probably help. Zoom in to wherever you plan to look, and you should start seeing all sorts of different airplanes. Now you'll notice that also the map looks a little bit different this time around. I just decided to change it over to satellite instead of just the regular map, so you can see a little bit of a difference. You know, it looks a little bit more like an actual map. And we're already seeing a ton of things coming through here. Look at this, Archiver. It's so pretty.
Yep. We have planes coming in from Wales.
From
so you're
Wales.
not just seeing Dublin, you're seeing it as far as Wales and England.
Yes. Now mine, you did show me previously, and I got a screen capture of it, what you are seeing through your Wi-Fi Pineapple, and it looks eerily similar to what I can see as far as which airplanes you're able to see and everything. So I don't really see any kind of loss of connection between you and us over here in San Francisco, which is great. Wouldn't you agree?
Yep. It looks really clear. It's a brilliant piece of kit.
It's beautiful. So if I run down the menu, of course, you can see everything like we used to. Ryanair, I'm not really familiar with any of these aircraft, actually. There's a green one in here with a cute little shamrock on its butt, which is awesome. Ryanair again. So I'm seeing about 1, 2, 3, 4, 5, 6, 7 on the map currently, and then there's 2 other ones which haven't determined their location at the moment, but they were sending some kind of ping requests out.
Mm-hmm.
How many are you seeing on your side? Same amount?
Right now I have 7
Awesome.
on screen and 9 in the list.
Yeah, me too. Okay, perfect. So we are seeing the exact same amounts. That is so cool. I love this program. It is so much fun. Archiver, I want to know, have you found any other programs out there other than what we've talked about on the show for use with your antennas at home?
Not so much. At least I found one or two that I'm still testing. And
Yeah.
once I've tested them a bit more, I might send them in via feedback at hak5.org, and you guys can take a look too.
That is so, so cool. I love Virtual Radar Server. I love that it's open source and that you can do so much with it. I have a feeling that there's plenty more about all these programs that we checked out that we just haven't figured out yet. So if you guys have any kind of opinions, comments, or questions, or you have a program that you want me to check out as far as antennas go, let me know. Feedback at hak5.org if I can talk correctly. And Archiver, thank you so much. Yeah, I know, right? Thank you so much for being on the show again. It's such a pleasure to talk to you, and thanks for staying up late. I know it's super late over there.
Yeah, glad to help.
Well, I
Always happy to help the
appreciate
show.
it. I appreciate it so much, and it was good to talk to you again. If people want to find you, where can they go?
Google Plus or Twitter. At Archiver on Twitter. It's the easiest place to get me.
Awesome. At Archiver on Twitter, and I'm at Snubs on Twitter if you guys want to comment about Virtual Radar Server or other programs. Let's check out some trains coming up soon. But I think it's about time to go. Thank you so much, Archiver, and let's get Darren out here to chat more about what's going on in the Hak5 universe. We're back, and it's time for the Technolist photo of the week, and this one is from Chris from the UK, who is checking out some Hak5 in front of his log burner blazing.
It's about as blazing there as it is in here, let me tell you.
It must be really hot there. I hope this picture is from like the winter time, because it looks very hot.
Why are we in the studio on a day like today? We really should. That's actually,
so
I feel like
hot.
we haven't been in the studio in weeks.
I know, well, we really haven't. It's been like 5 weeks. It's been quite a while. But we do have something happening pretty soon in about 2-3 weeks.
Yes.
And that's
on
going to
the
be out
8th.
of the studio.
Oh, yes. And that is going to be at the place with the bottomless mimosas and the German pancakes. We're talking about the Bay Area Hacker Brunch.
Yeah,
and it's
buddy.
going to be at our favorite place. So come on out to Point Richmond, which is totally not Richmond. It's totally quaint Richmond. You're going to love it.
Safe Richmond.
Yes,
There's free parking.
Yes, it's pretty awesome. And so yeah, San Francisco Bay Area, you can find out more information about the Hacker Brunch on Sunday the 8th at hak5.org/brunch.
/brunch. That's a week before my wedding.
There you go. You have just a few more days to get your proposals in.
Panic! Congratulations,
To
everyone.
To you?
Even though I'm probably going to say no. Sorry.
Oh.
Sorry, guys.
Wait, are you going to say no at the altar? That's messed
No!
up, Shannon. Why would you lead him on like this? That doesn't make any sense.
No, I would never do that.
Uh-huh.
That's terrible.
Okay.
I'm going to bring my Google glasses to the...
Are you going to get married with Google Glass on?
No, the officiant's going to wear it.
Okay.
You know.
For real?
Yeah.
Oh my god, I don't want to spoil. No spoilers. For real?
For reals.
Oh my god.
It's going to be awesome.
Oh my god. And no, that's the crazy thing is your wedding photos are going to have it's going to be like the priest holding a Palm Pilot, not even a Palm, a Sharp Zorus. I can't, the brain can't fathom the amount of you are ruining to get both these. One with and without. Are you serious? You have no idea
Yes.
how Model T the Google Glass is. In 10 years, we're going to be looking at that thing being like, look at this monster.
It's going to be awesome.
It's going to look like
the officiant's going to wear it,
silverback
and
iPhone.
he's going to record it from his point of view. So we'll get that close-up point of view, and then also the photography and the video from
I'm
my
happy
buddy
for you.
who's
That's fantastic.
take a video. I got my fiance to agree to approve my idea.
To TCP, RDP, SSH. This show's about tech.
Yes.
Right. So on that,
Glasses
feedback at hak5.org is where you can send us your favorite protocol. Is it GRE? Is it UDP? I don't know. I'd tell you a joke about UDP, but I'm afraid you might not get it. Hey, we have a garage sale coming up.
We do?
Actually, it's kind of a concurrent
That's
one.
awesome.
No. We have
I have so much stuff I need to sell.
No, we need to put, there are 8 now left of these. So let's just put them in the garage sale. HAKshop.com, it's where you can go and get yourself some software-defined radio stuff, Wi-Fi Pineapple stuff, and
Hack
however
RF
many
stuff.
shot glasses happen to be available.
Hack RF?
Yeah, Hack RF is
Stuff.
I'm playing with it right now. I've been doing some FM stuff with it. I can't wait to break out the GNU Radio Companion and show you guys. It's been pretty cool. Yes, that's enough for right now.
Yeah,
Like that.
and hak5.org/follow to find everything that we're up to, including the brunch.
Yes. Cheers. And also, I'm Darren Kitchen. That's Shannon Morse. Trust your technologist. See, they need to like pull us off.
Where's
the set.
Evil Server?
He's right there. He's right there.
Oh, he's hiding.
He's literally right. It's
There
like
he
the
is.
Enterprise. There's a bunch of panels and stuff everywhere. See? Hey, Paul, I found the socket wrenches.